Hello, folks, and welcome to Multiplying and Dividing Rational Expressions. So we are going to not just multiply regular numbers, we're going to multiply things that have x's and terms and all that good stuff. So you need your notes, a pen or a pencil, your calculator, and your thinking cap with factoring. You got to know all the different kinds of factoring. All right. So first and foremost, let's make sure that we know what the objective is today. The objective is to be able to multiply and divide rational expressions, but also at the same time simplifying them. Okay, so we want to know how to multiply and divide, but the big idea here will be able to simplify them because the multiplication and the division part will be the easiest part. So you got to know the rules. So first, when you multiply fractions, you always multiply fractions straight across. So if I have 1/4 times 1/5, you take 1 times 1, which is 1, and 4, and 4 times 5, which is 20. So 1/20th would be the answer to that problem. Remember, we're not adding, so we don't need a lowest common denominator, okay? We're multiplying. We do different things. When we divide fractions, we take the second fraction and we flip it, and we make the whole problem into a multiplication. So if I had 1/4 divided by 1/5, I would say that's the same thing as 1/4 times the reciprocal of 1/5, which would be 5/1. Now we apply the rules of multiplication. 1 times 5, 5. 4 times 1, 4. Then what we would do is we would always make sure that we simplify our fractions at the end if possible. Okay, so always make sure you simplify your answers. Okay, so now I have a rational expression, and I am multiplying these two rational expressions. What you need to think about first is, no, we don't want to take 2x squared times x and get an x cubed or get an x fourth, because we're not going to be able to do anything with x cubes and x fourths. I mean, factoring those, we're going to have to use p's over q's. Yikes, I don't want to do that. So what we should do first is we're going to factor first, okay? So if we can factor all the numerators and all the denominators, then the multiplication and the division is so much simpler. Okay, so I'm going to go ahead and factor this numerator. I think they have a 2x in common, so I'm going to take out a 2x. That leaves me an x minus 5. I'm going to factor the bottom. That's the difference of two squares, so that would be x minus 5 and x plus 5. And then we're going to take that times x plus 3 over 2x squared. Now that x plus 3, that thing is together. We can't factor that, so I'm just going to put parentheses around it so I know that I can't really do anything more with it, and I'm going to leave it. Now what I'm going to do is I am going to multiply all my factors together, but I'm going to leave them as factors. So I'm going to say 2x times x minus 5. We take all the numerators and we multiply them together. Okay, it doesn't mean we really need to multiply them together. We can just say they're being multiplied together. Works for me. Now we're going to do the same thing with the bottom. Now, see, what I tend to do is I like to line all the ones that look kind of the same on top and bottom of each other. It makes canceling way easier. So I'm going to say 2x squared here times x minus 5 times x plus 5. Now, you don't have to do that. I just do that. Makes it easier. Now, I have all the numerators on top being multiplied, all the denominators on the bottom being multiplied, and now I can cancel things that are factors. Okay, remember, don't cancel things that'll make you make a kitten die. We don't want any kitties dying, but we can cancel factors. So 2 divided by 2, oh, that cancels each other out. An x divided by an x squared, well, 1 here and 2 here, so this one is going to cancel, and I'm going to be left with 1 down here. This x minus 5, remember that's a whole factor. It looks just like the bottom x minus 5, so it's gone. So the answer to this problem would be x plus 3 over And I got that silly little x there times x plus 5. So it's a lot like what we did with simplifying yesterday, but a little bit different because we're going to put all the numerators together with multiplications, all the denominators together with multiplication, and then we're going to go ahead and simplify it. Excuse me. Let's try another one. 4x squared minus 4x. Let's factor that. We can take out a 4x. What are we left with? X minus 1. Let's factor the bottom. 1 times negative 3 is negative 3. Two factors of negative 3 that make 2 are 3 and negative 1. I'm going to put those in my, so 3x, put those in my squares. And factor the top, that's the x, negative 1 in common, x in common, 3 in common. So it would be x plus 3 and x minus 1 times, now we're going to factor the top. 1 times 6 is negative 6. Two factors of negative 6 that make 1 would be 3 and negative 2. So then I do x squared plus 3x minus 2x minus 6. Do my squares. What do they have in common? X, negative 2, x, 3. So what would go on top would be x plus 3 and x minus 2. And then the bottom cannot be factored, so we'd leave that as 4 times x. Okay, again, multiply straight across, so all my numerators multiply together. So 4 times x minus 1 times x plus 3 times x minus 2 all over 4 times x minus 1 times x plus 3. And that's all that's on the bottom. And then because everything's lined up and everything is being multiplied, I can see what would cancel. 4 divided by 4, x divided by x, x minus 1 divided by x minus 1, x plus 3 divided by x plus 3, and all I'm left with is x minus 2. Okay, let's try again. Now if I'm multiplying by something, I'm just going to go ahead and put that over a 1. Okay, so x plus 2. Yeah, it can't be factored, so I'm just, it's together. I'm going to put it in a parenthesis so I don't forget. X squared minus 4, that's the difference of 2 squares, so that's x minus 2 and x plus 2 times, multiply what's on top. We got to factor that with the AC method. 1 times 9 is 9. 2 factors of 9, that makes 6. That'd be 3 and 3. Make my squares. I got x squared plus 3x plus 3x plus 9. x3, x3. It'd be x plus 3 times x plus 3. And then we have over 1. So we're just over 1. Okay? Now put everything on top together. X plus 2 times x plus 3. And we could really say that's x plus 3 quantity squared because there's 2 of them. X minus, we'll put the x plus 2 first. Then we'll do the x minus 2. And times 1, we don't really need to take that times 1 because anything times itself is 1. And then we'll cancel what looks alike. The x plus 2's look the same. So we're left with x plus 3 quantity squared over x minus 2. Now, could you say x plus 3 times x plus 3 over x minus 2? Certainly. Both of those answers will work. Okay? Let's try a divide. So what does divide mean? It means you take the second fraction and you reciprocate it. Okay, you do the reciprocal. So 2x over 3x minus 12 times x squared minus 6x plus 8. Now, some of you are like, well, can I just factor it? And as I'm factoring it, flip it? I would say you could do that. Many people forget to flip it right away, and then you do the problem incorrectly. So my suggestion to you is to go ahead and flip the numerator and denominator before factoring it, and then go ahead and take care of factoring. So this would be 2 times x, that can't be factored. Looking at the looking at the denominator now, what's in common between 3 and 12? That would be a 3. So I can take a 3 out. Multiply a times c here. That's 8. 2 factors of 8, that makes 6, would be -2 and -4. Do my squares. The x squared minus 2x minus 4x plus 8. That would give me an x, a -4, an x, and a -2. So I'd have x minus 4, x minus 2. And then the bottom now, which was the numerator to begin with, is not an AC method, but greatest common factoring. It looks like I can take an x out. That would give me, divide both of these by x, and that would give me x minus 2. So now I'm going to go ahead and multiply the numerators times the numerators and the denominators times the denominators. Like I said before, I like to line them up. Makes canceling way easier. 3 times x minus 4 times x minus 2. My x minus 2's cancel, my x minus 4's cancel, my x's cancel, and I'm left with 2 over 3. All right. Well, that is the end of my PowerPoint. Thanks for taking good notes. Hope you are doing well at factoring, and we will practice this tomorrow.